kind of have this feeling like I'm standing on the bridge looking out the window. I have a very strong feeling of being at the forefront, being out there exploring myself. That's the thrill of it for me.
The view from Cassini's bridge exceeds anything seen before.
Lo and behold, as we got close enough, it looked like the rings dissolved into all of these, individual ringlets looking a lot like grooves on a phonograph record for people who remember phonograph records. And it was just very exciting then to try and figure out what could be causing that structure. What looked like rather featureless rings in a telescope now had, thousands of features in them.
I was surprised at how surprised I was at the clarity of the images, because I thought to myself, well, for Pete's sake, I've been thinking about this for years. For 14 years I've been thinking about this. I've been planning these images for a decade or whatever it was. You'd think I would have, anticipated, well, we're going to have this kind of resolution, it's going to look like this, and I just hadn't.
For the first time, vivid details of Saturn's rings are revealed, beckoning us to stare in wonder for a closer inspection. Everyone is familiar with the rings of Saturn. But what would you highlight if it were you sending back the postcards? Every tour itinerary has one main attraction. With Saturn, you just can't miss the rings. As imaging team leader for Cassini, Carolyn Porco has had a ringside seat.
The rings consist of just countless particles, and they range from big boulders the size of small apartment buildings, all the way down to the finest dust particle and everything in between. And they're all orbiting like crazy around Saturn at 20 to 40,000 miles per hour, but it's like traffic on a highway. Everybody can be going 90 miles an hour, but relative to each other, they're going very slowly. If you could put a spacecraft there and you could manage to move at the same speed, then the speed wouldn't be that dangerous at all.
You can think of rush hour on a Friday night, on the freeway, that the B ring has a lot of traffic and a lot of particles, whereas you go to the A ring, it's a little bit better. The C ring is more like being out in the country. You aren't going to see ring particles too often.
Possibly the remnants of a failed moon. The ring particles have been flattened by gravitational forces into a super thin disk, nearly 200,000 miles across. Edge to edge, that's almost the distance from the Earth to the moon.
I have, in fact, imagined myself orbiting Saturn, hovering over the rings. It's hard not to.
I could just imagine what it might be like to hold a ring particle in my hand and see, what does it look like? Is it like a fluffy snowball? If I start to pull it apart, what's it like on the inside? So you can think of each of the rings, A, B, C, D, like different beaches. And so you'd want to collect samples from each of those rings.
And the icy grains on these Saturnian beaches are washed by passing traffic.
When a moon comes by, it creates a wake, just like a motorboat creates a wake that goes behind it. And I kind of imagine the ring particles doing an intricate cosmic dance around the planet, and can almost picture like little ballet dancers, each with their own orbits and paths, and sometimes colliding and encountering, and sometimes not.
Deeper secrets of this cosmic ballet are revealed, courtesy of a seasonal trick of the light. Once every 15 Earth years, as Saturn makes its slow trip around the sun, summer swaps hemispheres. In 2009, Cassini was in a perfect position to witness equinox on Saturn.
The sun at exact equinox will be shining exactly edge on to the rings, but a little bit before and a little bit after, The sun will be low to the rings, just like the sun is now low over London. Any vertical protuberances, either up or down below the rings, will cast very long shadows. And we have in fact found that the rings aren't completely flat. There are places where the ring particles in fact form these structures that soar a mile or 2 or 3 above the plane of the rings. The first time in 400 years, we now know that the rings are three-dimensional.
Enormous and enormously complicated. The rings also form a major part of Saturn's amazing weather machine. Upon arrival, you might be slightly disappointed that the cloudy face of Saturn looks a little plain. But the planet beneath the rings is wild at heart. Saturn's apparently peaceful appearance is due to a haze of high-level ammonia in the upper atmosphere. By looking deep into Saturn in the infrared, using the planet's own internal heat as a light source, Cassini has revealed the planet's true nature.
The winds on Saturn vary dramatically from the equator to the pole. In fact, at the equator, we have huge winds. We're getting close to 900 miles an hour now, near the speed of sound in that planet.
The winds are stronger at Saturn than they are on Jupiter, and that's a surprise because the two planets are rather similar in terms of basic composition. They're both gas giants. And yet Saturn has less sunlight to power the winds, and the winds are stronger.
Try explaining the six-sided vortex at the North Pole.
Saturn has a hexagon. It's some kind of a wave, but it's a permanent wave. It's been there since Voyager discovered it back in 1980. So this is just one more example of how atmospheric features, which are basically nothing but gas, they last forever on these giant planets.
There is another permanent storm at the South Pole. Not quite as strange, but gigantic in size. At 5,000 miles across, you could almost fit the whole Earth inside.
The South Pole has something that looks very much like a hurricane eye, except the clouds are 5 times the height of the eye wall around a terrestrial hurricane.
So it's kind of a window into the depths of Saturn, showing us just how dynamic the planet really is, and it's really kind of neat.
And at the bottom of this window, storms within the storm. Adding their own level of complexity to the weather forecasts of this alien planet are the rings. For half a Saturnian year, the rings block the light in the northern hemisphere, and the other half of the year, it's blocked in the southern hemisphere.
We are interested in studying seasonal changes on Saturn because of this extreme effect of the rings. Already we know that the sky was blue when the northern hemisphere came out of the ring shadow, and it's now turned sort of pinkish, yellowish, hazy color because somehow smog developed in the atmosphere of Saturn once the sun started shining. Probably not too different from smog in Earth's atmosphere, organic compounds or something.
For a planetary weatherman like Andy Ingersoll, Saturn has it all.
If I had an airplane that could fly in Saturn's atmosphere, I think it would be a wonderful sight to be surrounded by rings. It wouldn't get dark at night. There's more light on the night side of Saturn from the rings than there is from the full moon on Earth. So you could certainly read a newspaper on the night side of Saturn.
There'd be no shortage of strange stories to read by ring shine in the Saturn Express. And a lot of breaking galactic news. For Saturn is far from the only show in town.